All right, it's time for our first R coding challenge. This is sort of like a quiz, except you've got a week to complete it. So this week's challenge is going to be relatively easy, except for the fact that this is probably your first time trying to do something like this. So your task this week is to recreate figure 2.3 from our textbook, this figure here. And ideally you would not just recreate it, but also modify it a little bit. Do something, maybe change the colors, maybe change the title. Do what you want to make it a little bit different. So in order to do that, let me show you first off some pointers about how to set things up. I'll do kind of a dummy version of this so that you can see how to submit and what I want you to submit, and also to give you some pointers about how to work on these sorts of things. So what you want is, first off, you've got RStudio open. You probably want to set this up in its own project. So a project is RStudio's way to kind of bundle some things together. Now I've already got a folder in my Dropbox for this class, but let me create a new project. I'm going to create a new project just for this challenge specifically. So you might include multiple challenges in the same project, but in this case, I'll just create a whole new project for this. So new project, new project. Let me find where we are, fall 20, 390 challenges, open, and then I'm going to create a folder for this called challenge 1. You could create a Git repository, but don't worry about that for now. We'll just hit create project. So that's going to give me a blank display of RStudio, and it should have me already operating in this folder. So something to be aware of is R is operating in specific folders on your system. So if you type getwd, that gives you the working directory, and I can see I'm exactly where I think I'm supposed to be. Now, if you hit Control-Shift-N, that'll create a new script, and let's go ahead and immediately save that. Let's call it your last name challenge1.r. So you're going to be submitting this file once you get it working, and you're going to create an image using this script. Now, something I like to include in my scripts is this little bit of code. Let me show you what this does. So very often you'll be working at this and you'll be doing various things and you'll figure something out. A lot of the times you'll be kind of going back and forth with R over here. So you might say, hey, maybe I need something from Anscombe. So you got some data set and you say, hey, that's what I want. And so you go plot Anscombe and you run that and hey, you get this plot. But if you solve it on the console and you don't put it into your script, you lose your work. It becomes really easy to lose what fixed the thing. You want the script to sort of organize stuff as you figure it out so that you can run the script all at once. So the script is going to be multiple lines of our code. So I might have something like data is going to be Anscombe. So you figure out, hey, Anscombe is what I want. And then you figure out you want to plot Anscombe. And then when I hit source, it goes through, it runs this line, which clears everything out. It does this, and now I've got a script that is doing all the stuff I want in order. Now, if I'd figured out something like, oh, let's say I'd figured that out. Sorry, that's Lola. She wants her WALK. She's going to have to wait until 3 o'clock because I got class. So let's say we figured out that this is how we get our thing. We say data is going to be Anscombe, and then we plot data. And so we get this part in our script, but we forget to move what we learned from our console into our code. When we hit source, it's going to run everything, but there's no such thing as data, so it returns an error. The expression didn't evaluate to a length, data set X not found. It's kind of hard to tell what that means, but basically what it boils down to is it was looking for this thing called data, but I didn't define that thing called data. So what I can do is I can go back through my history, which so far isn't too bad, and I can say, let's move this not to the console, which is down here, but let's move it to the source code up here. So now if I save this and I run it again, now when it runs through, it imports data, it shows it up here on the environment, and when it calls to plot data, it doesn't return any errors, it just does everything that I want it to do. So that's a really simple script. This little bit of line is a simple thing you can do to clear out everything that you've got in this line. In your workspace. So if I just run this line on its own, that's going to clear out my workspace. ls shows you everything that you've got running right now. So if we go do this again and we run ls, we're going to see we have this object called data. So this says remove this stuff. And specifically it says we're going to list out the stuff we're going to remove, and that is going to be all the stuff we get when we run this function. So you've already seen this, but let me just explain it again. If you've got a function, the basic form is some function name and then some parentheses and then some arguments. This isn't going to work because, this isn't going to work because it's expecting something else. But where was I? I lost track of my thoughts. Right, what a function is. So in this case, the function is ls, and then parentheses, and in this case, there aren't any specific functions that I need to give it. If I just run it without arguments, it just shows me everything on my workspace. If I run rm and I say, I want to remove data, that's going to remove that one specific thing. In this case, I only had one thing in my workspace, so it wasn't a big deal. But as your projects get more complicated, this little line just makes it so that you are ensuring your script does what you want it to do. Think of your script as something you can hand off to someone else. It's able to do the work for you, right? So you really want to make sure that your script is working. Now, we've been doing that. We've been keeping it saved. We've been doing this in DataCamp. So as we do this, unnecessary comment, we make some little change, we save it, and Dropbox automatically syncs that. So figure out whatever system works for you. I've been using Dropbox for a long time. It works to back stuff up. Another service I use is pCloud. You guys might use Google Drive or OneDrive or whatever. Use something like that so that if something goes wrong with your computer, your work is backed up and you can move to another computer. That said, for this assignment, what we've got here, let me show you the simplest possible way to get this plot exported. So I want figure 2.3, but let's just pretend like this was the code necessary to get that. Then you can just go to export, click there, click save as image, and let's just call it figure 2.3.png. And now I've got this in this file. And so when you go to submit, you can go to here, click into the assignment, and you just upload those two files as attachments. Let's make sure this works. Go to challenge 1, give me your script, browse my computer, give me the figure, and maybe something went wrong. You say, sorry, prof, I couldn't get it to work, blah, blah, blah. If you can't get it to work, really what you should be doing is coming to office hours and trying to talk through it. But don't sweat it, right? It's better to give me something than to give me nothing, because giving me something gets you 4 points. So you hit submit, it uploads. Submission from previewed assignment is not saved. I don't know what the hell's wrong with that. So maybe it's going to give us some problems this time around. I'll try and figure out what the problem is. So in this case, if you're running into that problem, just email me both of these things as an attachment. Give me your R script, give me the image file, but hopefully Dropbox works for you. Maybe it's just giving me problems because I'm logged in as a professor. So again, what I want is I want a script, I want a file, an image file of your recreation of figure 2.3 from the textbook. You should be setting that up in a separate project in RStudio. So create yourself a new project, and then that way you can flip back and forth between things. So you're working on your project somewhere else, or you're working on an econometrics project. You can go ahead and save your work here and move over to your other stuff without creating chaos and disorganization. All right, good luck. We'll talk more about this in class in 20 minutes.